graphs together with the number of turning points can help determine the degree of a polynomial function. In this section, you will learn that different polynomial functions follow a specific pattern by looking at its end behavior, or how the opposite ends of a graph or of the graph of a polynomial function behave. This will help you easily identify the type of polynomial function based on its graph. Okay, so for example, for each of these examples, we will take note of the degree of the function as well as the sign of the leading term. For our first example, we have p of x equals x squared. So the leading term here, is x squared, which is positive. Now, if you look at the graph carefully, we see that both ends of the parabola, the left side as well as the right side, approaches to positive infinity. Meaning, as the value of x decreases, or as the value of x approaches negative infinity, this side of the graph, the left side of the graph, approaches positive infinity. While on the other side, as we try to increase the value of x to positive infinity, we see that this side of the graph, the right side of the graph, also approaches positive infinity, or the value of y approaches positive infinity. In this case, we describe the end behavior as y approaches to positive infinity as x approaches positive and negative infinity. Meaning, as x decreases or as y increases, the value of y increases to positive infinity. So this is how we describe the end behavior for this function, p of x equals x squared. Now this time, let us look at the graph of p of x equals negative x squared. Take note that both of these graphs are graphs of a parabola or of a quadratic function which is of degree 2. Here, the leading term is negative x squared. So this is how this graph is different from this one. The leading term here is negative, while the leading term here is positive. Now for this graph, if we look at the graph, we see that the left side of the parabola decreases without bound, meaning the value of y here decreases to negative infinity. Y approaches negative infinity as we decrease the value of x here. As we decrease the value of x to negative infinity, we see that the value of y decreases without bound to negative infinity. While on the other side, if we try to increase the value of x to positive infinity, we see that the right side of the graph also decreases without bound to negative infinity. Here. So again, as x decreases, y also decreases. On the right side, as x increases, y still decreases. So for the end behavior, we say that y approaches negative infinity as x approaches positive or negative infinity. For our next example, this time we have a cubic function or a polynomial function of degree 3. So here, our leading term is x cubed. Again, it's positive this time. Now, for a cubic function with a positive leading term, generally this is how the graph behaves of a cubic function with a positive leading term. We see that as x decreases, as x approaches to negative infinity, if we look at the left side of the graph, the value of y decreases without bound. Y approaches to negative infinity. On the other hand, as we try to increase the value of x, as x approaches to positive infinity, if we look at the right side of the graph, instead of decreasing without bound, similar to the first examples, this time the value of y increases without bound. So here, we see that for a cubic function, the end behavior or the left and the right side of the graph behaves differently. While for the first two, they both go to the same direction. For cubic function, they go to different direction. For the left side, y approaches negative infinity, while for the right side, y approaches positive infinity. So in this case, we say that the end behavior is y approaches negative infinity as x approaches negative infinity, and y approaches positive infinity as x approaches positive infinity. So this is how the end behavior of a cubic function is different from the end behavior of a quadratic function. For our next example, we still have a cubic function. So a cubic function this time with a negative leading term. Leading term for this one is negative x cubed. So here, same function, x cubed, but different sign for the leading term. Here, it's positive, and then the other one is negative. See how different the graph behaves. So here, if we look at the graph of negative x cubed, p of x equals negative x cubed, the left side of the graph increases without bound. Meaning, the value of y here increases to positive infinity as we decrease the value of x to negative infinity. So as the value of x decreases, we see that the graph or the left side of the graph increases without bound. On the other hand, if the value of x increases to positive infinity, we see that the right side of the graph this time decreases to negative infinity, decreases without bound. So this time, the end behavior is that y approaches positive infinity. For the left side, y approaches positive infinity as x approaches negative infinity. Y approaches positive infinity as x approaches negative infinity, while for the right side, y approaches negative infinity as x approaches positive infinity. That would be the end behavior for the graph of p of x equals negative x cubed.